In this video, we are going to talk about the top 10 mind-blowing facts about our planet. So before starting, please like this video and subscribe to this channel for future updates. Planet Earth. Since people first walked on the blue marble, it has attracted them. Why should we care? It's also our home and where life as we know it began. Over the years, we've learned a lot about Earth, increasing our fascination with it. How well do people know Earth? How much do you know about Earth's surface after a lifetime? Here are 10 more interesting Earth facts. You probably know a lot. Number 10. Earth is the only planet known to have life. The foundational elements of life have been found on Titan, a moon of Saturn, as well as historical evidence of water and organic compounds on Mars. In deep space nebulae, amino acids can be seen. Additionally, researchers have made assumptions regarding the potential for life to live below the ice surfaces of Titan and Europa, moons of Saturn. However, only Earth has really been found to have life. However, scientists are developing the experiments that will help find out if there is life on other worlds. The Nexus for Exoplanet System Science, NXSS, for instance, was newly established by NASA and will spend the ensuing years searching through the data returned by the Kepler Satellite Telescope and other missions that have not yet been launched for indications of life on extrasolar planets. Number 9. Earth has one moon and two co-orbital satellites. You probably already know that Earth has one moon, aka the Moon. We won't go into much into there because there is a lot that is known about this body and we have written numerous articles on it. But did you know that there are two more asteroids orbiting in tandem with Earth? These two asteroids, named as 3753 Cruithne and 2002 AA29, are a member of a larger group of asteroids known as near-Earth objects, NEOs. Asteroid 3753 Cruithne, which is also known as Earth's second moon, is 5 kilometers across. It has a coordinated orbit with Earth, but does not really orbit it. It also has an orbit that gives the impression that it is moving in the same direction as the Earth, but it is actually traveling in a different direction around the Sun. In contrast, 2002 AA29, which is only 60 meters across and orbits the Earth in a horseshoe shape, passes within 95 years of the planet. It will seem to circle Earth in a resemblance of a satellite orbit in around 600 years. It might be a good target for a space exploration expedition, according to scientists. Number 8. A year on Earth is in 365 days. There are 365.2564 days in a year. This extra is it. Leap years are required every 4 years since there are 2,564 days in a year. We add an extra day to February every 4 years because of this 2004, 2008, 2012, etc. With the exception of years that are divisible by 100, 1900, 2100, etc., this rule does not apply to them, 1600, 2000, etc. Number 7. Earth doesn't take 24 hours to rotate on its axis. Astronomers refer to this period of time as a sidereal day because it takes the Earth 23 hours, 56 minutes, and 4 seconds to circle once entirely around its axis. What does that mean exactly? Doesn't it imply that a day is 4 minutes shorter than we believe it to be? You could assume that as time passes, day by day, night will eventually become day, and vice versa. However, keep in mind that the Earth revolves around the Sun. The Sun travels by around 1 degree per day in relation to the background stars, which is roughly the size of the Moon in the sky. Due to the Earth's orbit around the Sun, we can observe a small amount of motion from it. If you add this to the Earth's rotation on its axis, you get a total of 24 hours. A solar day is defined as the length of time it takes the Sun to return to the same location in the sky, as opposed to a sidereal day. Knowing the difference between the two entails understanding how long it takes for the Sun to rise and set once, as well as how long it takes for the stars to appear at the same location in the sky. Number 6. The Earth's molten iron core creates a magnetic field. With poles at the top and bottom that are close to the real geographic poles, the Earth is like a giant magnet. The magnetosphere is an area formed by the magnetic field it generates that extends thousands of kilometers from the Earth's surface. Be thankful for the magnetosphere, which is thought to be produced by the molten outer core of the Earth, where heat causes convection motions of conducting elements to produce electric currents. Without it, solar wind particles would directly impact the Earth, exposing the planet's surface to high radiation levels. Instead of harming us, the magnetosphere guides the solar wind around the planet. Additionally, it has been proposed by scientists that Mars' thin atmosphere results from a weaker magnetosphere than that of Earth, which allowed solar wind to gradually take it away. Number 5. The Earth's atmosphere extends to a distance of 10,000 kilometers. The Earth's atmosphere is thickest during the first 50 kilometers or so from the surface, although it extends out into space for around 10,000 kilometers. The troposphere, stratosphere, mesosphere, thermosphere, and exosphere are its 5 principal layers. As one ascends higher into the sky and moves away from the surface, air pressure and density often drop. Near the surface of the Earth, the majority of the atmosphere is located. In actuality, the first 11 kilometers above the planet's surface contain 75% of the Earth's atmosphere. The greatest layer is the exosphere, which starts at the exobase at the top of the thermosphere at an altitude of roughly 700 kilometers above sea level and extends to a distance of about 10,000 kilometers, 6,200 miles. Exosphere and empty space in outer space, where there is no atmosphere, converge. The exosphere is primarily made up of heavier molecules including nitrogen, oxygen, and carbon dioxide as well as hydrogen and helium, both of which have extremely low densities. The exosphere no longer functions like a gas because the atoms and molecules are so widely apart, and particles are continually escaping into space. These free-moving particles travel in and out of the magnetosphere on ballistic trajectories and may also move with the solar wind. Number 4. 70% of the Earth's surface is covered in water. Astronauts saw the Earth for the first time with human eyes when they first entered space. Their findings led to the Earth earning the moniker Blue Planet given that the oceans encompass 70% of our world. This is not surprising. The solid crust that is positioned above sea level makes up the remaining 30%, which is why it is referred to as the continental crust. Number 3. Earth is mostly iron, oxygen, and silicon. Iron would make up 32.1% of the Earth's composition, oxygen would make up 30.1%, silicon would make up 15.1%, and magnesium would make up 13.9% of the Earth's composition. Of course, the majority of this iron is actually found at the Earth's core. There would be 88% iron in the core if you could actually descend and sample it. Additionally, you would discover that oxygen makes up 47% of the Earth's crust if you took a sample. Number 2. Earth is almost a sphere. The Earth is commonly believed by many to be a sphere. In fact, this was the accepted scientific theory from the 6th century BCE till the present. The Earth is truly shaped like a flattened spherical, though, as a result of advancements in astronomy and space exploration, aka an oblate spheroid. This form resembles a sphere but with flattened poles and a bulging equator. The rotation of our planet is to blame for the Earth's bulge in this instance. This indicates that the distance between the poles is approximately 43 kilometers less than the diameter of Earth at the equator. Although Mount Everest is the highest mountain on Earth, Mount Chimborazo in Ecuador is the landmark that is furthest distant from the planet's center. Number 1. Plate tectonics keep the planet comfortable. Only the planet Earth has plate tectonics in the solar system. In essence, the Earth's crust is divided into sections called tectonic plates. These can interact with one another and are perched on top of the Earth's magma core. One plate will subduct, move underneath another, when two plates contact, and where they rip apart, another crust will form. There are several reasons why this process is crucial. It is essential to the carbon cycle and causes tectonic resurfacing as well as geological activity, such as earthquakes, volcanic eruptions, mountain building, and the creation of oceanic trenches. The ocean's small plants sink to the bottom as they die. The carbon-rich remains of this life are recycled over a very long time period inside the Earth's interior. This removes carbon from the atmosphere, preventing us from experiencing a runaway greenhouse effect like Venus did. Without plate tectonics, the Earth would become hot and hellish since there would be no way to recycle this carbon. What do you think about our video? Let us know in the comment box below. Please like this video and subscribe to this channel for our future updates. Thank you.